I'm not going to promote you like I did to Oren, and I'll present you, I guess, as a lead in AT&T R&D Center in Israel.
Yeah, thank you.
Now I've been accurate.
Good afternoon. I really appreciate you guys have a fully packed agenda and stayed until this hour, so I really appreciate that. Before I start, two important comments. You will see no formulas in my presentation. The second comment is no cats have been harmed during the make of this presentation, but I do believe that their superpositions have been embarrassed from this joke. So let's start. So my name is David Bachar, and I'm a senior cybersecurity lead at AT&T. I must say that quantum technology, alongside their unprecedented potential to positively, but in the same time negatively, impact our day-to-day lives, has created an emerging force that cannot be ignored anymore. So during the next 15 minutes, I would like to take you through a journey how service providers, and specifically AT&T, has created a strategy to become a post-quantum secured organization. After that, we're going to speak a little bit about the market dynamics, and we're going to finalize with key takeaways. So just for the sake of the alignment, I'm pretty much sure that you're aware to that fact, but every time we open a secure connection towards, for example, the internet, we are following three major steps. The first step is the authentication. The second step, it's the key exchange, and lastly, the encryption itself. Some of the classical algorithms, such as elliptic curve, are using prime numbers mathematical problems, which are actually being known to be solvable by quantum computers. But as quantum computers are yet to arrive, so we need to ask ourselves, why should we worry now, right? We are worried because major organizations coming from the federal government, healthcare, financial institutes are pretty much afraid from the fact of what it's called harvest now, decrypt later. They are worried about the fact that malicious or bad actors will harvest the traffic, store it, and anticipate for the coming of the quantum computer to decrypt the traffic and eventually to expose our sensitive data. So before I will share with you our strategy in becoming a post-quantum secured organization, we started with a why. Like Simon Sinek says, start with why, and we've created our mission statement, which goes as follows. Protect AT&T, and most importantly, AT&T customers from the cybersecurity threats due to the quantum computation, and secure the information assets in which our customers have entrusted us. So how do we reach that mission statement? With 5 steps, and I'm going to review them one by one. Starting with the security awareness, sounds like an easy task, but actually we need to educate our entire workforce, and most importantly our managers, to make them aware to the security risks by the time the quantum computers will arrive. And since it's a relatively new, I would say, domain, you must engage with standardization bodies like NIST, like ARIS, like GSMA. Actually, GSMA just created a task force in September 2022. Actually, it includes more than 50 participants, leading vendors, and 20 of them are telco service operators. And the outcome of this task force, called PQTN, Post-Quantum Telco Networks, actually are a set of documents with relevant use cases and some implementation guides how to become a post-quantum secure organization. I really encourage you to follow them. The second step is to create a crypto inventory of assets. Look at organization at the size of AT&T. We have thousands of different applications. We need to create an inventory of those applications. We need to be aware which protocols they are using and which crypto libraries they are using. So how do we do that? How do we create this inventory of assets? So if we have an access to the source code itself, we can scan the code repository for the use of crypto libraries. We're going to need to search for references in the code to certificates, where we can identify information that relates to the authentication part. We're going to look for references to algorithms, either the symmetric keys or asymmetric keys, and scan the code also for keys and signatures for integrity protection and so on and so forth. If we don't have an access to the source code itself, meaning this is relatively an old application, we're going to need to have tools that will help us to scan through the compiled code. So again, we're going to scan for artifacts for the crypto libraries, keys, certifications, and also we can scan and collect the configuration of the runtime configuration, in some cases called Kubernetes as well. Third type of code that we need to search to is for those deployed codes. Here, we need to have tools that will help us to scan the host's operating system, again, to collect all the valuable crypto information that we can gather. Lastly, when we are referring to data in transit, it's a common thing to deploy network probes. Here we will see in the actual traffic, the actual data that's traversing throughout the network elements, maybe load balancers, reverse proxies, secure web gateways, any end device that terminates a secure connection, collecting all the relevant certificates and protocols, and by that getting additional visibility into that. So after collecting all this crypto inventory of assets, the next step is to actually calculate the risk assessment. So we said that quantum computers are yet to arrive, right? So the next question is, what is the value of our data? If my application actually holds one-time password, what is the value of the data in the next minute? Does it have a value? If my application holds credit card information, the data value remains valid for 3 to 5 years. Should I invest in upgrading this application to be quantum protected? But if my application stores or holds information that relates to medical records, DNA information, any kind of, I would say, private equity or IP, intellectual property, sorry, or any kind of information that relates to nation-state security, this data should be treated as sensitive data, and we must protect these applications first. So running this risk assessment, the result of that risk assessment eventually would be what we called a migration urgency score, which will indicate the priority of which application needs to upgrade first in order to become a post-quantum secured application, and it also will indicate what kind of mitigation measures I will deploy in order to protect it. Which brings us to the next step, to the mitigation itself. So we have two types of mitigation. The first type of mitigation will be IT mitigation. In a second, I will elaborate more about that. And the second mitigation will be network-based mitigation. So what it means, IT mitigation? IT mitigation means that we need to modernize our IT infrastructure. Maybe the software, maybe the hardware, deployed on-prem or in cloud. We need not only to upgrade our post-quantum cryptography algorithms on those specific applications and network elements, but we need to create an environment, as Inbar from Microsoft stated, should be crypto-agile. Because we do anticipate that after a certain period of time, those crypto algorithms will be breached and eventually deprecated, and we need to upgrade to a newer version of crypto algorithm. Us as an organization, we're anticipating to upgrade, of course, once NIST is going to announce the de facto winning PQC algorithm that it looks like Crystal Kyber. Some would say it will happen during this summertime. Some even specifically noted the date 17th of July, but I cannot really commit on that. We need to start our journey to upgrade those applications to PQC algorithms, but we don't really know what will be the performance impact of those applications once they're going to be upgraded to PQC algorithms. So for this sake, here at AT&T Israel, we have created a benchmarking performance tool called Kuyata. If you will scan this 2D barcode, you will get a direct access to our GitHub repository, and by that you can clone this amazing tool that will help you to better understand what will be the performance impact of your applications once you're going to upgrade it to PQC algorithms in a sense of memory, CPU, and so on and so forth. A little bit about the architecture itself. It's based on a client pool, based on kernel engines, and server pools based on Nginx. And we have our control and monitoring engine that helps us to collect the following metrics as CPU utilization, memory, throughput, concurrent connections, session initiation times, and many others. By the way, it can run on a Docker and also Kubernetes environment as well. Again, I urge you to clone this open source, work with that, and also contribute to further extend that. The fifth step would be network mitigation. Thank you for that. And in network mitigation, we have three different types of mitigation capabilities. We can establish a PQC tunnels. I'm going to discuss that a bit more. Of course, we heavily discussed about QKD solutions. Alongside the great security potential that QKD has, it has several limitations that I'm going to explore in a second. Here, whereas digital QKD comes to the rescue. And lastly, we have QRNGs. I know that QRNG is not a full mitigation to quantum risks, but it further extends the security levels by using better entropy level from QRNG engines. It could be deployed on the end device itself, but alternatively could be provided in a entropy as a service mode that can be delivered by service providers as AT&T. So in regards to PQC, if a specific organization would like to connect its branch with its headquarters, you just need to establish a VPN tunnel, a PQC VPN tunnel between the branch and the headquarters. It doesn't need the help of a service provider in order to do that. But as we all probably know, VPN doesn't really scale. So in that sense, service providers may consider to build an overlay PQC tunnel environment by connecting its core elements with IPsec tunnels utilizing the protocol IKE version 2, and further extending those tunnels until the endpoints of its customer, and by that allowing customers to connect from his branch to his headquarters or even to its public cloud applications, and benefiting from a secured end-to-end PQC tunnel connectivity. Second alternative in regards to network mitigation would be QKD solutions, which is considered today the most protected, I would say, technology out there in the market. But alongside the great benefits that it brings, it still has several limitations. The first limitation is the distance. Some would say 100 kilometers, some would say a bit more, some would say, hey, we have satellite QKD connectivity to further extend that, but it's still a limitation. And while speaking about nationwide deployment, I'm not speaking about Israel, of course, I'm speaking about the scale of United States, it is a challenge to deploy that as a nationwide. We may consider to deploy that in a specific geographical location, such as Washington, DC, for example, where we have a lot of FedGov customers that would benefit from this technology. Besides the distance, the cost is quite an interesting issue. For a pair of Alice and Bob end devices, we need to spend several tens of Ks of dollars. And this is also a challenging issue. And of course, all the operational complexities relates to managing this technology. So this is where digital QKD comes to the rescue. The goal of digital QKD is pretty much the same goal of QKD. It's an out-of-path capabilities to generate a symmetric key between two end devices, but opposed to QKD, which require dedicated fibers and dedicated hardware, we are running that on a classical network. It's not the same security level as QKD provides, but could be considered as a nice alternative to do so. So I'm running real quickly. Hopefully this video will work. So you can see on the lower part of the diagram, in the lower part of the diagram, you see the VPN client and a VPN server trying to establish a secured connection between themselves. And in order to do so, the client actually tries to reach the entropy as a service engine. I will do it this way. To create an entropy, the entropy will be shared with key management entities that will take this entropy and translate that into a fraction of a symmetric key. It's not a symmetric key itself. Then the KMEs will send those fractional keys to the client. The client will not share those keys with the VPN gateway. And instead of that, it will share only its client ID and will tell him the IP addresses of those KMEs that generated this fractional symmetric key. The VPN gateway will fetch those fractional keys, and according to a predefined recipe that both the VPN client and the VPN gateway will have, they will create the end-to-end symmetric key, establishing a secure connection and benefiting from that. Okay. The video didn't work, apologies for that. 2 last minutes in regards to the market dynamics, and with that I will finalize my talk. So many of the analysts predict that once NIST is going to announce the winning PQC algorithms, is going to accelerate their market. We heavily spoke about the driver of harvest now, decrypt later, but the regulations are also pushing the market to start their post-quantum journey. At the same time, there is a lot of market dynamics. Many vendors would like to be ahead of the curve, technology savvy. We'll see several examples coming from the financial market in that sense. And there is available budget. There's a lot of national funds available to accelerate this phenomena. And here we can see MasterCard and HSBC actually saying that they already started their post-quantum security journey to protect their customers and so on and so forth. By the way, if you would like to become a PSS 4.0 compliant, I know it's a bedtime story, but if you will read the entire document and specifically go to page 176, you will see that the best practices to become compliant, you need to have a crypto-agile environment. So once a crypto algorithm will be deprecated, you need to upgrade that to a newer one. So what is the market opportunity? I've gathered several market reports here. You can see that everyone has its own crystal ball. But you can see that in average, the total addressable market, and here it refers to QKD technology, is something between $5 to $10 billion by 2030, with double figures of compound average growth rate, which is quite impressive. Which means the requirement is there, the market is there. We need to start working on providing mitigation solutions. Also, the telcos and the vendors are taking a front seat in this sense. Vodafone, BT, Singtel, SK Telecom, all of them either started POC or deploying live network, as for example, Singtel did for the sake of their government. Also, the vendors, Microsoft, we heard about them today. Juniper, Cloudflare, Cisco, even Apple announced February this year, they have developed their post-quantum protocol called PQ3, and it's designed to protect their iMessage application. So what are my key takeaways? First of all, again, NIST is going to announce the PQC algorithms. It will accelerate the post-quantum readiness activities across organizations. The second thing, please consider Kuyata as a performance benchmarking tool. Download it, clone it, and use it. Thirdly, network-based solutions are a great alternative versus IT modernization, which is a very costly solution. And lastly, and most importantly, let's get started and prepared today. Thank you.